Good morning to everyone. Today I am going to discuss with you very important technique of operation search, that is a transportation problem. It is a technique of operation search which is used for preparing the distribution policies of the organization. In other words, we can say it helps the management to know how many units should be sent from each source to each destination, so that not only the demand is satisfied, at the same time the supply is fully utilized or exhausted and the related cost can be minimized. There are certain steps involved in the transportation problem to find out the optimal solution. The first one is we have to make it ensure that whether the matrix is balanced or not. In the transportation problem, a matrix is said to be balanced when the total of demand is equal to total of supply. However, in many of the cases the demand is not equal to supply, then it is a case when the matrix is unbalanced. To make it balanced, when we have to introduce the dummy source or the dummy destination as the case may be. After making the unbalanced matrix balanced one by introducing the dummy source or the dummy destination as the case may be, the second step is to find out the initial feasible solution. In the transportation problem, there are three methods to find the initial feasible solution. The first one is northwest corner method, second is least cost entry method, and third one is the Vogel's approximation method. From the three methods, the Vogel approximation method is most prevalent and most used because it provides the solution which is more nearer to the optimality. Then the third step is to find out whether this initial solution is basic or not. Initial solution will deem to be basic if it is satisfied the condition of rim requirement. According to this rim requirement, initial solution will be deemed to basic if the initial allocation will be equal to m plus n minus 1, where m refers to the rows and n refers to the number of columns. Sometimes the initial solution fails to satisfy the rim requirement, which results in the problem of degeneracy. To resolve this degeneracy, we have to introduce a dummy allocation which is called as epsilon, and it is denoted by capital E. While introducing the epsilon in the unoccupied cell, we have to keep in mind certain important factors or take into mind certain consideration while introducing this dummy allocation having value 0. The first one, epsilon will be introduced in one of the unoccupied cell. It means the allocation of or allotment of this unoccupied cell epsilon in the dummy row, the dummy column where the allocation is not made. Second, compare the cost of all the unoccupied cell and epsilon will be introduced in the cell having least cost. Third one, which is most important, before introducing the epsilon in the cell, ensure that allocation do not create any loop, whether it is rectangular or in square. If it is so, then shift this dummy allocation the epsilon to the next higher empty cost cell. And the fourth and the last one is avoid introducing epsilon in the dummy row or the dummy column in the first step to make the matrix balanced. These are the 4 points, and the last step is find out the optimal solution. After making the solution basic, the next step is to check whether the solution is optimal or not. For this purpose, there are two methods to find the optimality under the transportation problem. The first one is modified distribution method, and second one is the stepping stone method. In the upcoming videos, I will discuss in detail how to find the initial feasible solution by the three methods, whether it is the northwest corner method, least cost entry method, or the Vogel's approximation method, and how to find out the optimality with the modified distribution method and stepping stone method. Jai Hind, Jai Bharat.